Hey everyone, welcome to the open elective course on Vehicle Design Engineering. This course is offered by Department of Automobile Engineering, and the introduction about myself is I am Santosh, Assistant Professor, Department of Mechanical Engineering, and I am handling All Day Center of Excellence in charge as well as the technical trainer for the final year and third year mechanical students. So this is my phone number 9942248287, and my email ID is santosh@drmcet.ac.in. So I am going to handle the vehicle design engineering. So let you go through with the course outcome. At the end of the course, we are expecting you to get an knowledge about first CO. Course outcome is convert customer voice into appropriate vehicle specification using HOQ, that is House of Quality. And second CO, they explain the function of structural parts and dynamic subsystem and identify the key specifications. Third CO is design the part of a subsystem or the entire subsystem like structural parts, suspension, brakes and wheels. And the fourth CO is explain the various materials, design, standards applicable globally for automobile industry. And fifth CO is recommend a suitable test for testing the parts subsystems of the vehicle as per the requirement of stakeholders and regulation standards. So let me explain the each and every CO with the help of the syllabus. Then only you can easily understand about how the CO and the syllabus are interlinked. The first one, unit 1, which deals with the CO1, quality function deployment, QFD. Mechanically, technically speaking, QFD means quality function deployment. Here, the raw data which are all given from the customer is been converted into the technical specifications using House of Quality. For an example, the recent trends in the automobile two-wheelers or four-wheelers, we can easily say that the electric vehicle, the boom of an electric vehicle is coming to picture. Here, if you are interested and ask some of the customers what kind of an electric vehicle you are having or what kind of an electrical vehicle you want to buy, they given a data like the vehicle should run at XY kilometers, or the speed should be this much, or the design should be like a commuter bike like that, or a scooter type of bike we want. Like that, they can give their raw data, the raw customer inputs, which is being converted into the technical input. Like if we want to make this much amount of kilometer range, we have to build the battery capacity of this much, or 3 cell battery or 4 cell battery we have to give, or lithium ion or lithium phosphate or aluminum oxide batteries, whichever we want to able to accomplish, that we have to decide. So the raw customer data is being converted into technical data, like the battery cells, type of a motor, how much kilowatt we are having, and what is the curb weight, like that we have to decide. So these are all comes in unit 1. And the unit 2 is subsystem specification. Here the subsystem specification like the frame of a vehicle, body of a vehicle, how the footrest, handlebar, parking systems should be look like that we can study. For an example, if you can see in a normal commuter bike like a Hero or a Honda Unicorn, and you can easily compare with an KTM sports vehicle, the frame structure itself, it is different. If you say the Unicorn, it is a commuter type bike and which is having 150cc, whereas a KTM Duke, you can say it is a framed structure or a trussed structure, and it is for this sports. Lightweight high speed vehicle is the Duke, whereas the Unicorn we are having a heavy weight as well as the normal commuter bike. So here the how the frames look like, how much weight it should have, what is the body structure, and how the appearance is being handled. So those are all we can study using unit 2. And whereas unit 3 static subsystem, so the CO 2 and 3 will be converged in unit uh, 3 and 4. This is the static subsystem. Static means that we have to study about the mass, geometry, moment of inertia, section calculation. So all the things, how much cost should be incurred, how much cost should be quoted, all the things we have to be studied in the static subsystem. And whereas in the dynamic subsystem, the safety parts like suspension, brakes, wheel, so these are all the safety systems. So the safety system design and how to calculate and how to optimize the dynamic system, and what are the materials involved in the dynamic system, how much costing is incurred for the making of parts or buying of a parts, like that we are going to study. In the unit 5, the both CO4 and 5 will directly adhere with unit 5, that is globally which material can be used for the automobile. For an example, if you see the recent days, every automobile will have a, definitely it is having a plastic bodies. So bodies are made up of plastics, whether it is a any kind of a bike or a car it may be. The plastic aesthetic items, all the things are being manufactured, that is globally adhered material, globally tested and advised materials we can have. And similarly we have a Euro norms or BS norms which has been standardized everywhere. So, and similarly for the testing we have an ARAI, ECE, AIS, IS, like that, global NCAP, European NCAP, like that. We are having a n number of testing and standardized systems. All the tests are being made with the global specification, should meet out the global specification. And the safety, which is very important. So the failure analysis, the testing gives the failure analysis, so it is very useful. Since in an automobile is a one such example where if you are irrespective of any stream, whether it is a core or a electrical or an IT stream, everyone can be converged, and say as a good example in an automobile. So since the mechanical student will design the frame, engine specification, all the drivetrains, whereas an electrical background candidate can specify how much fuel injection should be, what is the electrical components it should be involved, what are the parking systems it should be involved. And recent days the vehicles are come with the Bluetooth and EMU, engine management unit. So engine management unit is fully controlled with the help of an IT guys. So the according to us, we are humans. So the heart of us is very important. Similarly, for an vehicle, EMU, engine management unit, or engine measurement unit should be, engine monitor unit should be a heart of a vehicle. So the IT students and IT candidates can get a huge opportunity in two-wheeler and four-wheeler components or automobile expertise. So with this background, I will very happy if you are selecting the vehicle dynamics engineering, so that we can have a very good practical knowledge with a huge example about the subject and about the vehicles. Thank you. Thank you once again.